Going on now to the review of Chapter 7's tests. This time we're using Form B. So again, the questions are the same, the answers are the same, but they've been scrambled, so they're in different order and perhaps different letters. Okay, well let's start going through these. And again, we're going to stress strategy. So here we see the third root of 250. Now what we're trying to do is see if there is a perfect cube root factor of 250. So we divide it by 2 to start off, and lo and behold, we get 125, which is a perfect cube. So under one radical sign, we'll put the 125. Whatever's left over, we put under the other radical sign. We take the cube root of this, and we get 5. And the part that doesn't have anything else, we just leave. And that is answer C. Now, for strategy for powers of I, what we want to do is to convert the I into powers of I to the fourth. And you might say, why? Well, because I to the fourth is 1. So in I to the 19th, how many I to the fourths do we have? Well, we have 4 of them, because I to the fourth raised to the fourth power is I to the 16th. So this is 1, and then we're left with I to the third. And we know that I to the third is a negative I. So 1 times negative I is negative I. C. Here, this is sort of an easy one. The square root of this is 13. The square root of this is 3. Now, number 4, a little bit tricky. But what is negative I? Well, up here we said it was I to the third. So negative I is I to the third that we're going to raise to the 19th power. Well, 3 times 19 is 57. Now, how many I to the fourths do we have in 57? Well, we have 14 of them, because 4 times 14 is 56. So in a sense, we could separate this into I to the 56 times I. Or if we leave it this way, I to the fourth is 1. 1 to the 14th is 1. So that leaves us with an I. So 1 times I is I. Example B here, or answer B. All right, let's move it up a little bit. Here they want us to write an equivalent expression using exponential notation. Well, again, the review of all of this is that if we have a number, let's say x, and it's in the form m over n, that would be a fractional exponential notation. That converts where we take our base, and that becomes the radicand, that's an x. And our denominator is the index number, and our numerator is the power to which our radicand is raised. So if we see something in this form, the 2 then is going to be the denominator, the 7, the numerator of our base, which is in a sense the radicand there. Now notice I like it this way because you can really see a numerator, denominator. Denominator is always the index number. Now theoretically they shouldn't have put a 2 there. They did that just to help you because we don't write the 2 there. Okay, now this was an easy one. Square root of 81 is 9. And if we took that 2 there and divided that by 2, we get a 1. And again, they're saying the answer is the absolute value of y, which is correct. But I will also accept this, as I said in class. All right, number 7. Now we have a negative under the radical sign, but since it's to the 3rd root, that's okay. Now how would you calculate that or put that in your calculator? Well, you'd put that in a parenthesis and then caret, and this is to the 1/3 power. So you would then put 1 in parentheses divided by 3, close parentheses, and then this would come up as your answer, -8. So if you cubed -8, you would get a -512. Now here you need to be careful because they're asking you to rationalize the numerator. So we have 3, or the 3rd root of 7. Now what would be the perfect cube of that? Well, it would be 7, you have one of them, so you need another 7 and another 7. So that would be 7 cubed. Well, here we have 1 7, so we have to multiply it by 49 to make it then a perfect cube, whatever number that would be. It's 7 to the 3rd. And then when you take the 3rd root of that, it just becomes 7. Now in our denominator, remember we're multiplying this fraction by a 1 in this form. So it's still 3rd root. 2 times 49 is 98, and you bring the x along, and that's your answer. And they have it here as D. Now, for techniques in solving this, again, I would write it in the proper way. I don't like the way they've written it there. We want to get this to be just plain y, so whatever denominator, we raise it to that power. So it becomes 3/3, which is 1. That gives us our y. But if we do it to this side, we must do it to that side. So 6 to the 3rd power is 216. And then here, again, the technique is to square both sides. Or if this is to the 2nd, to get rid of the radical sign, we have to raise it to the 2nd. Then we just get the radicand, but we have to square the 7. That gives us 49. Then we transpose the -7 to this side, becomes a +7. Add it to 49, we get 56. Divide both sides by 8. We get Q equals 7. Right there. Now this one, where it might look challenging, is pretty easy because you're just going to square both sides. That gives you then the radicand. And then this equals that. We're going to subtract 3a from both sides. We get 5a. Add 2 to both sides. We get 11. Divide both sides by 5. We get a is 11/5. Right there. Now again, you want a strategy for doing these. They want you to simplify this. So we had said the strategy was to set up two radical signs, put our index number there, and then look through this and say, is there a perfect square factor of 8? Well, 8 is a perfect square, so that would go under the first one. Now, I'm sorry, it was cubed. And then what's the perfect cube of x to the fourth? Well, x to the third. And there's one x left over that I put here. All right, I have y to the fifth. Well, a perfect cube of that would be y to the third, and there's 2 left over. So now under this radical sign, they're all perfect cubes, which I now take the cube root of it. Cube root of 8 is 2, x to the third is x, y to the third is y, and what is left under the other radical, and don't forget the index number. Okay? And that's D. Okay, number 13 now. Here they want us to use rational exponents, that is fractional exponents. So we said this was the index number that we place under our exponent, which is the numerator. We just do this division and we get 6. Now that's the answer they want. If you actually expanded that, it would end up looking like this. These two are equivalent, but this is not given here. This is the answer. Now to multiply something like this, it's going to be the fourth root. We just multiply our radicands. And this is 20 times 10 is 200. Are there any perfect fourths in 200? No. And you could factor that and see there were no perfect fourths in there. And there it is right there. Now, for number 15, they want you to use the law of exponents to simplify. Well, first of all, I wrote it so I could understand it. And what are we going to do when we are dividing, in a sense? Well, we have to subtract exponents. Well, since they're in fractional form, we need to have common denominators to work with these fractions. So 2/3, I'm changing to 4/6. 1/6 is already there. I'm now going to move that 1/6 up. When it crosses that division bar, its sign changes, and it becomes 1/6, a negative 1/6. That gives me a 3/6 that I reduce to 1/2. And there it is in letter D. Now here we're asked to rationalize the denominator. So we can look at our 6 here, and we want to get 2 more 6's here. So it becomes a perfect cube. Well, 6 times 6 is 36. So this is my 1 that I will multiply the numerator and denominator by. So here, this just becomes 6 to the third. That will simplify to 6. And we go 5 times 36 is 180. And don't forget the index number 3. And they have it right there for us. See if I get my pen going here. Okay, there we go. Okay, number 17, they're asking us to solve this equation. It's in functional form. So it would be this equals that, which I have here. To get rid of the radical sign, we have to square both sides. When we have a 2 there and we raise it to that power, it just becomes the radicand, and this is 49. Transpose the -5 to that, and we get 54. Actually, some of these are a little easy, which is not too bad. And let's go on to number 18, where you're simply going to put this information into your calculator. And you might say, well, how do I do that? Well, hopefully you knew that it was going to be 13 caret 1/3 that you put in parentheses, this part here. And that's 1 divided by 3, enter. And then you round to the nearest thousandths, which is 3 decimal places. Okay, and here we're foiling. 8 times 6 is 48. Our outers are a positive 24i, inners a negative 12i, and last a negative 6i squared. Now these are like terms, so we're going to put those together as 12i. Now we also know that I squared is a negative 1. So a negative 6 times a negative 1 gives me a positive 6 that I convert. And now add that to 48. And that then gives me 54 plus 12i squared. Now for number 20, we need complex conjugates to kind of get rid of the imaginary number in the denominator. So a conjugate, remember, is the same terms, but opposite signs for the middle sign. Here it's a negative, there it will be a positive. I'm doing the top first. I get a negative 64 and a positive 16i squared. I FOIL the bottom. Now there are no middle terms. They just cancel out. I get a negative 8 times negative 8 gives me a positive 64. A negative 2i times a positive 2i gives me a negative 4i squared. But again, we know that I squared is a negative 1. So negative 4 times negative 1 gives me a positive 4 that I add to the 64, and that's where I get my 68. And I separate it because I have to put it in standard form for complex numbers. I simplify, and there's my answer, letter D. Now notice 21 is just adding, and they're added just as if they were variables. So 7 plus 9, 16. A negative 5i and a positive 8i, a positive 3i. Okay, we could erase it a little. Now here again, we're looking for technique and simplification. We put it all under one radical sign there. And 3 goes into there once, 3 goes into there 5. And the a's just cancel out. So I'm left with 5b to the third. Well, again, our technique is to put two sets of radical signs. Under one, we put perfect squares, which is b squared. And whatever's left over, 5b. We take the square root of this, which gives me b, the square root of 5b. Okay, that's letter B. Now for this, we write it in the proper form, x to the negative 1/6. We just bring it down to our denominator, keeping in mind there's a 1 up there in the numerator that we keep, and this becomes that. and they didn't want it in radical form, so there it is. Express in terms of I, well, we take out the square root of -1 and then the square root of 36. We said the square root of -1 is I, and this is 6. And the conventional way to write it is 6I, although this would be correct. Although in standard form, we always want the I at the end. So anyway, identify the radicand, which is what is under the radical sign, that's this, and the index number, which is a 2. Remember, we don't write the 2 there. All right, let's go on. Okay, 26, simplify. Again, our technique is to use 2 radical signs, put factors of what our original radicand that are perfect cubes. 8's a perfect cube, and of the x to the 16th, we get x to the 15th. That's a perfect cube. It's divisible by 3. And then whatever's left over, we put under another one. Then we take the cube root of 8, which is 2. The cube root of x to the 15th, just divide that by 3, gives us x to the 5. And we just write the other radical sign. And that was letter A. I guess they have trouble making smaller numbers there, but hopefully you can figure out. Okay, number 27 was tricky because it was this equals that. Now notice that's an even root. Can the even root of something equal a negative? And the answer is no. So that answer does not exist. And 28, I guess I gave you 2 of them, very similar. Again, the square root of something does not equal a negative, does not exist. All right, we're almost finished here. Number 29. Now, basically, they want us to write a fractional exponent into its radical form. So, we take our denominator of that rational exponent and use that as the index number. And then what's inside the parentheses becomes our radicand. And since it's just to the first power, we don't write it. So that one was pretty easy. Now, for number 30, 31, and 32, I've actually had a little room at the bottom of the page, so I've written them out there. So let's go there to look at them. So again, I put it all under one radical sign. We want to simplify. And can you see that this is 7 times 2? And there's another 7. And just get m to the 20th. Okay, now we're going to use our technique of 2 radical signs. All the perfect squares under one radical sign and what's ever left over under the other. So we have 7 times 7 there, which is 49. And then we have m to the 20th, which is, again, it's a perfect square. And we have the 2 left over that we put there. We take the square root of 49 and get 7. We divide the 20 by that 2 that's out there, and that gives us a 10, and then this is what's left. And whatever answer that was, that's it. Now, let's look at this next one just a little bit, because they're asking us for the domain of this. I guess it was under a radical sign. And again, under the radical sign, you can't have a number less than 0. So it has to be greater than or equal to 0, which when we solve it becomes a positive 19. On a number line, it would look like this. In interval notation, it looks like this. And that's your answer. And here they just want us to simplify by taking the cube root of our numerator, cube root of our denominator. I guess you ended up with a real easy one for the last 5/3. Okay, just under 26 minutes. And again, by noting where you had an error, you are preparing for your final exam.